Hi everyone. So today's problem of the day is minimum score of a path between two cities. And what is given in description? You are given a positive integer n representing n cities numbered from 1 to n. We are also given a 2D array roads where road I is equals to ai comma bi comma distance I, which is denoting that it is a bidirectional road between the cities ai and bi, and the distance between the city is distance I. The city's graph is not necessarily connected. The score of a path between two cities is defined as the minimum distance of a road in its path. Return the minimum possible score of a path between cities 1 and n. And we need to note that a path is a sequence of roads between two cities. It is allowed for a path contain the same road multiple times, and you can visit cities 1 and n multiple times along the path. The test case are generated such that there is at least one path between I and n, 1 and n. So, what if we will see this example? So, we will be giving one n. N is denoting that there are n cities till 1 to n. There are n cities, and road will be given as a comma b comma di. What it is denoting from cities A to city B, there is a distance di, and the city is bidirectional. That means we can move from A city to B city as well, and from B city to A city as well. And we need to find like what will be the minimum possible score. To find the minimum possible score, what we need to do, we need to travel from one city to the n city. And what is n in our this example? N is 4. So we need to travel from 1 to 4. And while travel from 1 to 4, we can visit any city any number of times. This is like the most important part, that we can visit any city any number of times. So if we are visiting any cities any number of times, so what will be the minimum path if we will see in this example? So one path is like we can move from 1 to 4 directly. What will be the score in this case? The score will be 7. So, and what will be the other case? Other case is like we can visit 1, 2, and then 5. What will be the minimum score in this case? Minimum score is the minimum of all distance. So in from 1 to 4, we have traveled 1 to 2 and 2 to 4. What will be the minimum? The distance are 9 and 5. What will be the minimum? 5 will be the minimum. So we can traverse like this also. So in this case we got 7, and this case we got 5. So what will be the minimum? 5 is the minimum. So we can return 5 in our answer. We will see second example. Second example, n value is 4. 4 means we need to traverse from 1 to this 4. So what are the we need to find the minimum score for minimum possible score. So what are the ways to go from 1 to 4? So we can go either 1 to 3 and 3 to 4. What will be the minimum value in this case? Minimum value will be the minimum of 4 and 7. What will be the minimum of 4 and 7? 4. This is the one. And next thing is, in our question it is given that we can visit any city any number of times. We can visit any city any number of times. So we can move from 1 to 2, then 2 to 1, then 1 to 3, and then 3 to 7. This is also a possible way. So what will be the minimum in this case? Minimum will be 2, 4, 7. The minimum. What will be the minimum of 2, 4, and 7? The minimum is 2, so we can return 2. So the twist in this case is like we can move any cities any number of times. So we need to find the optimal approach to solve this question. So what will be the optimal approach? The main part in this question is the main logic is like we can move any cities any number of times. So what will be the logical way to solve this question? So we are moving any cities any number of times. So if we are moving 1 to 2, then 2 to 1, then 1 to 3, and 3 to 4. So we are finding the minimum distance. So what if I will start from my first node, and then I will traverse to, and it is also given in the question that there is definitely one possible path from 1 to n. There will be definitely at least one possible path from 1 to n. So what we can do? We can traverse from 1 to 4, and we will visit any possible node, and we will take the minimum of that. So there is 1. So we will from 1 we can go to 2. Okay. So we can go to 2. So we got 2 as a distance. Then from 1 we can go to 3. So we can note 3. From 3 we can go to 4. So we can note 4. And we will take the minimum of all these distance. All the connected path minimum we can take from 1 to till 4. So this is an easy question only. Like we need to find, we need to see ki from 1 we can directly use a DFS here. Why DFS? Because it is an easy way to traverse a graph using DFS, because we can use the recursion, and recursion we can move to any cities. So we can use a DFS or VFS, anything we can use, but in our question we are using DFS, depth first search. So we will be moving from one city to every connected city. We know that there is obviously a one possible path from 1 to n. So we don't need to care about n. We just move from 1 to any to every connected cities, and we will take the minimum of that, and we can get the answer. The same thing I have done in my solution. I initialize my answer as int max, and I have used a visited to, so that if I am moving from one city to other city, I will not to take that distance again. I will not move the distance again, because it will increase our time complexity, and we want a time complexity to be minimum. So we will take visited array and then adjacency list, and then we will push all our cities with the distance in that adjacency list, and we will use DFS. DFS will start from one city, and we will pass visited and adjacency in that DFS function. And then what we are doing in DFS function, we will be marking that city as 1, and then we will move to all the connected cities from that 1. We will move to 2, then from 2, if there is any connected city, then we can move to that. Then from 4, if there is any connected city, we will move. So all the possible connected cities we will move, and we will marking this answer equals to minimum of the answer and all the possible distances covered in this path. And we will use the recursion for every possible cities connected to 1. And because we know that 1 and n will always be a one path possible path. So we don't need to find that if there will not be a path, what will be the in that case, because there is always a path. We don't need to care about n, because n it will definitely reach n. So we just need to care ki all the possible path we will cover from 1, and we will take the minimum of that, and we can return that in our answer. In this case, we have used DFS. So the time complexity in this case will be big of n. And the space complexity will also be big of n, because we have used adjacency list and also the visited vector. So yeah, I think you are able to understand this question. If you have any doubt in the logic or implementation anywhere, you can reach out to me in the comment section, and I will try my best to answer all your queries there. So yeah, thank you.